Having talked about the difference between independent and dependent events, remembering that independent events happen independent of each other. The outcome on one does not affect the outcome on the other. And then dependent events, where the outcomes do affect each other. Decks of cards, as I pull a card out of the deck, I change the deck, I change the probability. Having talked about that, let's talk about finding the probability of things happening where we're talking about dependent events, where the outcomes do affect each other. So for example, in the short story Burnt Toast by Mack Reynolds, Sheriff is offered 13 glasses, one of which is poisoned by the demon. His objective is to select a glass that's not poisoned. Once he's drunk in it, once he's had the glass to drink, he no longer has that glass available to him, so the number of glasses remaining drops. That affects the probability of him selecting one that has been poisoned. For example, if he starts off with 13 glasses, he has a probability of 1 in 13 of selecting the poisoned glass. Or, if you look at it from the other direction, he has a 12 out of 13 probability of choosing a safe glass, because 12 are unpoisoned. To keep our math simple, we're going to look at this from the standpoint of the word and the probability of drawing safe glasses. It makes the math a little bit easier to work with. Now let's say I want to do the probability that he will safely select 3 glasses. So, let's break this down into the 3 individual events. Event 1, he's presented with 13 glasses, he selects 1. 12 out of the 13 are safe to drink, because 1 out of the 13 is the poison glass. So, he picks 1 glass. 12 out of the 13 are safe to drink. So on a given selection, he has a 12 in 13 chance of safely picking a glass. That glass is now gone. That means 12 glasses remain. So the probability of him going on to then select another safe glass is 11 out of 12. There are 12 glasses remaining, 11 of them are safe. So, on his first selection, the odds favor him significantly, a 12 in 13 chance. To give this a percentage, or a decimal for us to consider, 12 out of 13 is a decimal of 0.92. 92% of the time, he'll safely select one. 11 out of 12, on the other hand, the odds aren't quite as good anymore. We're now down to 0.92. Now, this is 0.923. This is 0.17. So you can see a slight drop in probability, but the odds still favor him significantly on that given drink. The third drink, he's had 2 glasses out of the 13, which means now 11 remain. Of the 11 that remain, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them are safe to drink. 1 is poisoned. And again, the probability is going to change. 10 out of 11 is 0.909. We can see a steady drop as there are fewer glasses to choose between. Now, we deal with the word and. The probability that he will safely select a glass, and then safely select a glass, and then safely select a glass. The math hasn't been modified. The formula remains the same. I take the product. What makes dependent events different is I have to look at every event separately and work out the fraction or the decimal that represents its probability. Then I can merge them all into one. So if I take these guys, or take these, and I take their collective product. So I'm going to take 12 times 11 times 10, divide that by 13 times 12 times 11. I end up with a net probability of safely selecting 3 glasses in a row using this system of only 0.769. Significantly less than on a given drink. Because if you think about it, it's not just a matter of him safely selecting a drink on a given shot, it's having created this chain of events. That probability is somewhat less. And again, because they depend, I've removed a glass once I've had it to drink, I no longer have that same number to choose from. When we are talking about dependent events, the probability changes. What does not change is that when I see the word and, I'm talking about a product. So the probability of event A and B is still going to be the probability of A times the probability of B. Understanding that the probability of B may be modified by what came before when we talked about A. There's your basic formula then. Otherwise, the math remains the same. Take the product, that will give you the probability of the events happening in sequence.